Thank you. Okay, thank you very much. Good afternoon. I'm Nektarios. I'm Director of Research at FORT in Greece, and I'm head of the Remote Sensing Lab. And at the same time, I'm the coordinator of the project CURE, that stands for Copernicus for Urban Resilience in Europe. This is an international collaboration between 10 European countries. And on behalf of the CURE consortium, I will give you an overview of the project today. So this project has just concluded. It was funded by Horizon 2020 Space, and CURE provides the means to cope with Earth observation, data under exploitation in the domain of sustainable and resilient urbanization. We combine data and products from 4 Copernicus core services. That means the land service, the atmospheric service, the climate service, and the emergency service. This is why, because during the creation of these core services in Europe, there was not any special core service related to urban environment. However, since the urban environment is multidimensional, we need information and products and data from all of these different Copernicus core services to deal with urban research and applications. So, CURE introducing new ideas how to develop application across these Copernicus core services in the domains of climate change adaptation and mitigation, the healthy cities and social environment, and energy and economy. And here's the constellation of our application. We have developed 11 cross-cutting applications in the domain of heat, air pollution, CO2 emissions, hazards, and deformation risk. So different partners of this project have developed different applications. For example, FORT has developed applications related to surface heat island and heat storage. The heat emissions and the CO2 emission applications have been developed by the University of Basel. The thermal comfort and air quality applications developed by VITO. And surface heat island has been developed by DLR. Nature-based solutions developed by TECNALIA. Health impact from socioeconomic perspective developed by CWR and Appier in Denmark. And we have 2 applications related to land deformation and flooding developed by Gisat. So in this project, we have the user engagement from the beginning. We have 4 front-runner cities, which is Berlin, Copenhagen, Sofia, and Heraklion. And we have the 6 follower cities we see here. So we develop all these applications in the front-runner cities and then replicate to the follower cities. We have a continuous iterative cycle during the course of the project. We have information running from users to the CURE consortium through users workshops led by University of West England at Bristol and DLR, and then information running from the consortium to the users through the CURE system that was developed by GeoVille. So we have the continuous cycle during the whole of the project, and we have a kind of co-creation during this project. And we have here all these applications, the cross-cutting applications. These applications were not developed originally in this project, but mainly in past projects. In this project, they have just slightly improved. They have adapted to Copernicus just to get enforced by Copernicus data, and most important, have been Dockerized to be able to run on the cloud. So the system of CURE is a platform developing the European cloud, the DIAS, and we have specifically selected the VKO because this VKO DIAS has concentrated all environmental information, all the information of Copernicus core services, and all the satellite data developed by European space assets. And having Dockerized these applications and put them in Docker containers are able to run on the virtual machines we developed in CURE, because CURE has developed as a front office on a DS back office. And here you can see the different technologies that have been used. Cannot get on this and give more specific details on CURE system design. What should be noted here that we have developed a CSI, which is the Copernicus. An interface that to access the Copernicus core services automatically based on metadata and automatically fit all these applications with data. And we have developed specific interfaces for the case studies and for the specific users of the system. And all of this is the CURE portal. which is finalized, and you have access through this address. You can visit it now, and this is how the portal looks like. And there we have integrate all these applications, and we develop storylines for each application, for our case studies, and how these applications are connected. Here, for example, the storyline and the different modes of the launch of this application. And I have selected a few videos, for example, this one related to thermal comfort. Thermal comfort application is related to the indicator is the wet bulb globe temperature, the well-known application, is developed by VITO. They have the urban climate model, and the output of this model is adapted here with other information about form and function. This is an example of San Sebastian. And you see the standard case, the minimum, maximum, and mean globe temperature. And we have simulated several scenarios. For example, you see here to compare if we have different planning alternatives related to nature-based solutions, green roofs, solar ceiling, etc., and see what is the impact of this different alternative on this on thermal comfort based on this specific indicator. Similarly, for CO2, we developed this application for Heraklion. This is the case study of Heraklion. They have developed statistical models based on biotic and abiotic emissions of CO2. We have, of course, the urban form data. We have traffic data and vegetation data. And you see in this example here the difference between weekdays and weekends for the emission of the city of Heraklion. And it's obvious that we have the main roads of Heraklion with emission from traffic. And the user can just visit and separate the spring emissions with winter and have this type of comparisons as an example. Similarly, for urban floods, again, the case study of Heraklion, we have a coupled hydrologic model, and we have the flood hazard in its specific urban atlas polygon for the city of Heraklion. And then this information is combined with information we have from the local authorities about the age of buildings and vulnerability of different buildings, just to be able to assess the risk for its specific urban asset. Yeah. For nature-based solutions, another example. Here is the case of San Sebastian. Mainly in the left part, you can see the potential. That means it is mainly related to very high resolution DSM related to the slopes of roofs. And in the right part, you can see the prioritization, the priority, which is based on multi-criteria indicators, for example, related to the age of buildings, related to the border area of buildings, the percentage of vegetation in this specific neighborhood. So by moving the cursor, we can get information about the potential or the prioritization of each specific building, and then we can aggregate at neighborhood level. And we have, for example, graphics like this. We can see for each specific neighborhood of San Sebastian, which is the green area roof potential, and we have statistics with its specific neighborhood and also for the whole city. And last example, an air quality application. This is the example of Sofia. In the left part, you see the NO2, and the left part, the PM 2.5, as output of the model that is run by VITO. And you see that we have fine scale, different areas, and we see the different spatial distribution of the NO2 in comparison with the PM 2.5. And especially for PM 2.5, you can see the different concentration of each pixel, for example. And we can go in each specific sector and see, for example, here is the PM 2.5 emitted by traffic. And similarly, we can the sector for the residential sector, and it is obvious that this spatial distribution of PM 2.5 is mainly because of the emissions of industrial sector, whereas the emissions of NO2 is mainly related to the traffic. So several other examples you can find more in your website. So here we have the main outcomes of the CURE project. We have online platform combining Copernicus core services to support urban resilience. We have uniform data for large sums in urban areas across Europe. We have consistent measurements across European cities, including synergies between Copernicus core products and third-party data. And we have different approaches and models to better get informed about the urban form and function at different spatial and temporal scales. We have assimilated user knowledge with technical data, and we have benchmarking and supporting decision making in the domain of climate change mitigation and adaptation. We're happy to see 5 out of 10 of our case studies that have been selected to join the new European Horizon Euro mission on 100 carbon-free and neutral cities and smart cities by 2030. So now that the project has concluded, so based on this case study, we'll try to get connected to the mission board and try to get all this work and the system of CURE be adopted by the Commission to scale up the whole cities of the mission. So our vision is to CURE be a focused and evidence-based toolkit for assessing the current and the future policy making in the field. Now this summer, the consortium discussing about the core characteristics and the downstream characteristics of CURE, because CURE is the same time core and downstream. So how to exploit it? If we get the core path, we need to use this links to the mission, and can be adopted by Copernicus, and in practice to have a core service in the Copernicus. And we can also, here we have the full system, and if we follow the downstream path, then each of the CURE core cross-cutting applications can be implemented separately. In any case, the CURE is the first project that has concentrated all data information from all Copernicus entrusted entities, and for this reason, CURE has the potential to become, or at least to contribute to the urban development hub that will be developed by Copernicus. You can find more information in our website, curecopernicus.eu, and all this overview information, more detail in a paper that has been accepted and it's expected to publish next month in Scientific Reports. Thank you very much for your attention. Okay.
Yeah, thank you for this nice insight of the CURE project.